Right, okay, so you should have read the examples before exercise 8A, and then I'm proposing here that I'm going to solve the odd numbered questions and you guys solve the even numbered questions. So, right, go ahead then. So, question 1. You've got, it says the velocity is t sine t, so the velocity is dx with dt. So the x with dt is equal to t sine t. Now this differential equation is obviously variable separable. We're going to separate the variable, separate the x, keep the, I've said, haven't I, that you don't get a choice in which goes where. This has to be, because it's on the top, this has to stay on the top, and that has to go up to the top. So I'm going to move that up, if you like. So dx, the integral dx is equal to the integral of t sine t dt. Like literally that couldn't be easier. This one here though, I'll integrate this by parts. So x is equal to, and then this I'm going to integrate by parts late. So that's me u, that's me dv by dx. So du by dx is 1, and v is the integral of sine is minus cos. So the right hand side there becomes the it's uv, so minus t cos t minus the integral of v du by dx. So that's 1 times minus cos t. Go ahead, there's me minus. So cos t dt. So x equals minus t cos t plus, and then the integral of cos sine t plus c. Okay, so this is what we're talking about, where now you need to use the initial conditions, and the initial condition in this one is that I'm just going to write x there actually, and there, nice one. The initial condition is that when t equals 0, p is at the origin. Okay, so I'm going to sub in t equals 0, x equals 0. Okay, so 0 equals 0 plus 0 plus c, nice one. So x equals, nice that, minus t cos t plus sine t. That's it. Okay, show that when t equals pi over 2, p is 1 metre from O. Okay, so t equals pi over 2. Then x equals minus pi over 2 cos pi over 2 plus sine pi over 2, which is 0 plus 1, which is 1, which is what it asked us to do. Nice one. Okay, so that's question 1. Right, question 3. And then question 5 we'll do as well, and then use yourselves. I'll have to have a look at question 7 because it's a big one. Right, so question 3. Okay, so a particle P is moving along the x-axis. At time t, the particle has got velocity v in the direction x. I don't really need to draw a picture here because there's nothing really going on. But I just want you to be aware of the velocity is dx with dt. And there's our differential equation there. Okay. So I've got dx with dt is equal to, and there's a crucial word here in this question, what's really important, and it's the word decreasing. So as x increases, the acceleration is decreasing. Okay. That's d2 x with dt squared actually equals minus 4e to the 0.2t. Yeah, that was me not reading the question properly really. So it says acceleration, which is why this is d2x with dt squared rather than dx with dt. So I just thought it was going to be another velocity question, but it weren't. Okay, so when t equals 0, p is moving through the origin with velocity 20 meters per second. That's really interesting. I'm going to talk about that in a minute. Right, firstly, let's find v in terms of t, so that means integrate this. So, if we integrate this then, so we get dx with dt, which is v. I'm going to write that. I'm going to write v equals dx with dt, which is, let's integrate this then. So I'm going to write it. The integral of minus 4 e to the 0.2t dt, which is, that's minus 20 e to the 0.2t plus c. I need to use the fact that when t is 0, the velocity is 20. Okay. In the direction of x increasing, and this is important. I'm not just saying that when t is 0, v is, and the minus 20 won't do. It's actually 20. So let's put that in. 20 equals, I'm gonna say that's minus 20 plus c. The point is that when t is 0, obviously this term is 1. So that's minus 20 plus c. So c is 40. It's not 0, it is 40. Okay. Right. Yeah, that's it. That's v is minus 20